In this video, we want to solve all problems of Maclaurin paper 2023 from UKMT. There are 1, 2, 3, 4, 5, 6 problems. We want to analyze all of them, not only work on solutions. We want to see different approaches for some problems. I will list some homeworks for improving your problem solving. Okay, so let's start from problem number 1. A plank of wood has one end A against a vertical wall, its other end B is on horizontal ground. When end A slips down, so let's draw. Okay, it is vertical wall, horizontal ground. Let me show it like this. Then our wood is something like this. It is A, it is B. Then it says when end A slips down 8 centimeters. Okay, suppose it's x centimeters and it's y centimeters. In next step, okay, because A slips down 8 centimeters, x will be x minus 8. It will be something like here. X minus 8. And then it will be something like this. Look, it slips down. So here it says B moves 4 centimeters further away from the wall. So y will be y plus what? Plus 4. Now our B is here. In next step, it says when end A slips down a further 9 centimeters. So look again, 9 centimeters, something like this. So here it will be x minus 8 minus 9 will be x minus 17. And B moves a further 3 centimeters away from the wall. So y plus 4 plus 3, y plus 7. Find the length of the plank. So suppose this length is, for example, z. It is z. This length, it is z. So length of plank won't change, it's constant. Now we use Pythagorean theorem. We know that z squared in the first figure equal to x squared plus y squared. If we apply Pythagorean theorem, in next one it is equal to x minus 8 squared plus y plus 4 squared. At the end of this problem, I will tell you a problem last AMC 2022 that you can solve it with Pythagorean theorem. And last part, but harder than this, x minus 17 squared plus y plus 7 squared. Okay, now let's consider it is first term, second term, third term. First term equal to second term equal to third term. If we consider first term and second term, x squared plus y squared equal to x minus 8 squared plus y plus 4 squared. We have a famous identity, but you should know that if we have a plus b squared, you can write it twice and it will be a squared plus 2ab plus b squared. And if you have a minus b squared, it will be a squared. You should memorize them. They are so much basic and important. B squared. So for first one, it will be x squared. Here, minus 2 times x times 8 minus 16x plus 64. And next one is y squared plus 8y plus 16. Then we cancel x squared, we cancel y squared, and we write 0 equal to negative 16x plus 8y if we rearrange. 64 plus 16 is 80. Then we can divide both sides by 8. And it will be 0 equal to negative 2x plus y plus 10. Then we take negative 2x and y to left hand side. It will be 2x minus y equal to 10. Okay. So we call it fourth things or 4, equation number 4. Now I consider first one and third one here. If I consider first one and third one, x squared plus y squared equal to x minus 17 squared plus y plus 7 whole squared. Again, if we use our identities here, these two identities, the first one is x squared minus 2 times 17 times x minus 34x plus 289. And next one is y squared plus 14y plus 49. Okay. Now we cancel x squared, we cancel y squared. Then we write 0 equal to negative 34x plus 14y. If we rearrange, 289 plus 49. 9 plus 9, 18. We have 1. 1 plus 4, 5 plus 8, 13. We have 1. 1 plus 2, 3. Now we divide both sides by 2. 0 equal to negative 17x plus 7y plus 1, 6, 9. Okay, now we take these two things to left side. So 17x minus 7y equal to 169. So we call it fifth equation. Now in next step we use 4 and 5 to find x and y, then we can find z. So if we write 4 again, it is 2x minus y equal to 10. If we use fifth equation, 17x minus 7y equal to 169. Here, if we use replacement, we know that 2x minus 10, if we take 10 to this side, this right side equal to y, and if we replace it here, 17x minus 7y, y is 2x minus 10, equal to 169. So 17x minus 14x plus 7d equal to 169. And then we can say 17x minus 14x, 3x. 169, if you take 70 to right side, 169 minus 70. It's 99. So x equal to 33. And y is what? Y is 2x minus 10 here. It's 2 times 33, 66 minus 10, 56. The problem wants what? It says find the length of the plank, z. Z is x squared plus, z squared is x squared plus y squared. So z squared is x squared plus y squared. So it will be 33 squared plus 56 squared. And we want to find square root of that. Okay, let's calculate in a new page. 33 squared. 3 times 33, 99, 99, 9, 8, 0, 10. 1089 plus 56 squared. 6 times 6, 36. We have 3. 6 times 5, 30 plus 3, 33. 5 times 6, 30. We have 3. 5 times 5, 25 plus 3, 28. 6, 3, 11, 3. 1, 3. So 31, 36. 6 plus 9, 15. We have 1, 1 plus 3, 4. 4 plus 8, 12. Then you have 1, 1 plus 1, 2. 3 plus 1, 4. So here it is multiple of 25. You can say first 5 times 8, 22, 4. 25, 5. Again, you can say 5 times. You can factor another 5. That will be 134. 6, 45 is 9. So it's 5 squared times 13 squared. So because z squared, we proved is 5 squared times 13 squared. Then we conclude z equal to 5 times 13, which is 65. Okay, now let me tell you an algorithm. For example, here we could factorize and it was perfect square. But if it wasn't, let me tell you a more general way. Solution 2 here for calculating this part from, let me tell you, from this part that you want to calculate solution 1. From, I can say this part. 4225. It is so much useful in the exams that you can't use calculator. From right, you consider digits 2 by 2, then 42. What times itself is less than or equal 42 and greatest possible? 7 times 7, 49, greater, but 6 times 6, okay, 36. Then 625. Now we multiply 6 by 2, it's 12. And we multiply always the thing here by 2, and we draw circle like this. Now we should select greatest possible. If you select 1 to 1 times 1 times 1, it is less than this, but 2 also works. And if you check, 5 is the greatest possible. 6 to 5, 0. Now you take 5 here, 65. You can also continue. You can calculate square root with decimal digits, something like this. Okay? Now let me tell you homework that you can solve it with Pythagorean theorem. It's harder than this problem, but it's good to improve your problem solving. It's for M.Sc 2022. Let me find the problem. It is M.Sc 12A, problem number 20, and this is this problem. Isosceles trapezoid ABCD has parallel sides AD and BC with BC less than AD and AB equal to CD. There's a point P in the plane such that PA equal to 1 and PB equal to 2, BC equal to 3, and PD equal to 4. What is BC over AD? And these are the choices. You can solve this, and Pythagorean theorem is the key point of solving this problem. And except Pythagorean theorem, we have an idea double Pythagorean theorem. I call the name this because we use it many times. If you want to know double Pythagorean theorem is what? There are around 40-50 important formulas in geometry and also other topics. We have important formulas if you want to learn them. As I said before, feel free to send message to my WhatsApp number in the description and comments. Also, I released all solutions of M.Sc 2022. You can see the solution in my previous videos. Problem number 2, the digits 1 to 8 are placed into the cells of the grid. On the right, Pythagorean theorem is what? There are around 40-50 important formulas in geometry and also other topics. We have important formulas if you want to learn them. As I said before, feel free to send message to my WhatsApp number in the description and comments. Also, I released all solutions of M.Sc 2022. You can see the solution in my previous videos. Problem number 2, the digits 1 to 8 are placed into the cells of the grid. On the right, this figure, this grid making 4 3-digit numbers when read clockwise. Here, 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 here. For which values of k from 2 to 6 is it possible to create an arrangement such that all 4 of the 3-digit numbers are multiple of k? Okay, let's check k2 first. All these 4 numbers should be multiple of 2. So here should be even. For example, I place 2, 1 to 8. 4 here, 6 here, 8 here, then 812, for example, 234, 456, 678. So for 2 it was okay. Now let's check K3. Okay, so let me do something. For K2, we've solved. We found an example, and K2 is okay. It says find which values of K. So the first one is 2. Let's see. If we consider K3, some of these things should be multiple of 3. So if we consider 1, 2, 3, I think if we place them clockwise like this, it is good. 4, 5, 6, good. 6, 7, good. 8, but this one is not good. Okay, so let's, last part, last number, not good. 4, 5, 6, 7, 8. If you consider these numbers mod 3, or if you don't know modulo and divisibility is so much important. But if you don't know that, remainder when divided by 3. It is 1, 2, 0, 1, 2, 0, 1, 2. So we have 3 ones, 3 twos, 2 zeros. Now here, if we want to create a number that is multiple of 3, we should select 1, 1, 1, or 2, 2, 2, or 1, 2, 0. So because we have 2 zeros, I select 0 here and here. So 1, 2, 0, 1, 2, 0, 1, 2, 0. Let's see if we have 3 twos, 3 ones. And it is multiple of 3, multiple of 3, multiple of 3, multiple of 3. And if I write the numbers, I can write real numbers. For example, the first one, I write 1, 2, 3, then 4, 5. Then after 5, I place 6 here. Then 4k, 3k plus 1, 7 here, and 8 here. So 1, 2, 3 is okay. 3 sum of digits equal to 6, sum of digits equal to 12. Here sum of digits equal to 18, sum of digits equal to 15. All of them okay. So K3 also works. Now let's work on K4, 5, 6. If we check K4, so here for K4, we know these places should be even, okay? Now it should be multiple of 4. So let's consider when we want to know that a number is multiple of 4, last 2 digit is important. So because we have 4 places, this place should be even, because it should be also multiple of 2. So for one of them we place 2, we have 4 even digits. So for one place 2, 4, 6, 8. And odd numbers are left 1, 3, 5, 7 for other places. Now that we have 4 numbers, 4 odd numbers for other places, for 4 we have problem because 14 is not multiple of 4, 34 not multiple of 4, 54 not multiple of 4, 74 not multiple of 4. So any place that we have 4, the previous digit is not possible. For example, if this one is 4, then here, if you place any number, we have problem. Because a number is multiple of 4 if last 2 digits multiple of 4. So, as I said, 14 is not multiple of 4, 34 not multiple of 4, 54, 74. You should use an even digit here. But the even digits were used in these corners. Okay, so 4 is bad. Now we've checked 2, 3, and 4. Let's check 5. If we check K5, our digits are 1, 2, 3, 4, 5, 6, 7, 8. So we know this 3-digit number should be multiple of 5. So last digit should be 0 or 5. We have only 5. Again, here we should have 5, but we can't use 2 5s. We have only 1 5. So K5 is bad. And last case that we should check K6. For K6, because it is multiple of 6 is what? 6 is 2 times 3. It should be multiple of 2 and 3. So here we should have even. Okay. So in the corners, we should place 2, 4, 6, 8. Okay. Now, if we want to consider remainder when divided by 2. Now here we want to consider 3. Because we have 2 zeros, 3 ones, 3 twos. So, one way is to use for all cases 0, 1, 2, 0, 1, 2, and so on. 0, 1, 2, and zeros should be here. For all steps we place this like K3 that we've created. Or maybe we use also, for example, 1, 1, 1. Okay, so If only we have this, or if, for example, we have 1, 1, 1 or 2, 2, 2. Let's check these two cases. At first, I want to check case 2. If we have, for example, 1, 1, 1 here, then in this place we don't have 1. So we have to select what? 2, 2, 2. 3 2s. Okay. And without loss of generality, we consider 3 1s here. Okay, because if it is here, it will be the same. Now the 2 zeros will be this, and as you can see, all numbers are okay. But we know these 3 1s are what? The 1s are remainder when divided by 3, like the case here we've done for case 3. 3 1s are what? 1, 4, 7. One of them even, but we know because it should be also multiple of 2 here, should be even. Here also should be even, but between 1, 4, 7 we have only one even. So case 2 is impossible. Now let's consider case 1. If we consider case 1, because we have only 2 zeros, and for all 4 numbers we should use zeros, so zeros should be on the corners. Because if you use 0 here, we need 1 0, we need 1 0, we need 1 0, we need 1 0. Then with 1 0 you can't read all these numbers correct. So without loss of generality, zeros should be on opposite corners. We have 2 zeros here or here. But we know 1 0 is 3, 1 0 is 6. Without loss of generality, for example, 3 6, or we can say 6 3. But because of 2, corners should be even. But for 3 again we have problem. Okay. So for 6 also impossible. Now we proved our only cases that are good are 2 and 3. Okay, it was analyzing problem, consider different things. If you want to look here, we considered, I can say background idea is mod. Okay, and for mod, I can tell you different problems from BMO if you learn, and it takes, I think, 2-3 hours to get good at mod and be able to solve BMO problems. If you know divisibility. If not, divisibility also take 2-3 hours to get good at that. Then you can solve many problems of BMO1, also BMO2, and other exams like AMC, AME. If you want to learn mod, divisibility, how to work on number theory problems of BMO1, BMO2, considering a small example, important ideas, as I said before, feel free to send a message to my WhatsApp number in the description and comments. Problem 3. ABCD is a square and x is a point on the side DA such that the semicircle with diameter CX touches the side AB. Find the ratio AX over X. So let's draw the figure. Okay, it is our square ABCD, and then it says okay, X is a point on the side of DA such that if the semicircle with diameter CX. For example, this one, it says it should be something like this. Okay. So let's draw a better figure. Okay, so AX is this, the center is some point here. It is O. And it says find AX over X. So one thing that we know, if we have a circle and if you have a tangent line, if we connect O to this point, it is perpendicular. Okay, so here also, if we draw this part, because it is tangent, the problem says touches the side AB. So it is 90. And we know that it is radius, so it is parallel to this one, and we know that this one should be equal to this one. The ratios, when we have 3 parallel lines, this over this equal to this over this, you can easily prove it by similar triangles. So this one. And now here, you will see, okay, O is on perpendicular bisector of AB. If you continue this, you can see, okay, this is midpoint of this one also equal to this one. because it is perpendicular. This line, these two lines are parallel, and when this line is perpendicular to AB, it is also perpendicular to CD. Now, we understand that O is on perpendicular bisector of CD by definition of perpendicular bisector, then OC equal to OD. Or you can use congruent triangles. This triangle is congruent to this triangle. Why? Because this side, this side, this side is common, and two sides and angle between, which is 9. So now we understand what? We understand that if we consider a circle passes through DC and perpendicular to this, then it will be exactly the same circle. Now let me tell you another thing. If we consider this one, let's consider, name it Y. I want to say D or Y are collinear. Why? Because here, let me tell you, this is radius also, it is equal to this, it is equal to this. And we know our circle passes through D also if we continue this. So let's continue something like this, and we can continue like this. Okay, so let me do this and this. Okay. So this circle, and let me tell you, I can erase this part and draw a real circle. Okay, it will be something like this. It passes through C, D, and we know that CX is diameter. So by symmetry, you can say what? You can say also this is diameter. Okay, exactly, because they, with respect to B and C, this circle is symmetric. Now we want what? We want AX over XD. So let me tell you something. When you have a circle and you draw a common tangent, you draw a tangent, for example, this point P, it is A, it is B, it is C. It's so much important. PA squared equal to PB times PC. And try to prove it as homework 2 with similar triangles, okay? Now here, if I call this one M by this rule, AM squared equal to AX times AD. Okay. Now, I consider this length equal to A because it is a square. A equals, so AD equal to 2A. So AM squared is A squared. AX times AD. AD is 2A. So we divide both sides by A, so A equal to AX times 2. Okay. And then if you divide by 2, AX equal to A over 2. Now, AX is A over 2. XD is what? XD, the whole, it is 2A, it is 2A, the whole part is 2A, minus AX. AX is A over 2. So 2 to 4, 4A minus A, 3A over 2. Now, if we calculate AX over XD equal to A over 2 over 3A over 2. So we can say A over 2 times 2 over 3A. You can cancel this, you can cancel this, and it will be 1 over 3. So it is 1/3. It has lots of other solutions. And if you want to learn other solutions, and this point is so much important, that when you have something like this, I can say BMO round to 2022, it is equal to this. Okay, it is tangent chord angle, half of AB, arc AB. This one is inscribed angle, half of AB. The idea, homework 3, you can solve the geometry problem with exactly this idea, but that is harder than this. You should know also other things. But if I want to tell the other problem, BMO 2021. So let me paste the problem. Okay, this is problem 3 of BMO 2021. And also we have some problem for IMO, International Mathematical Olympiad. The IMO problem is so much hard because you should improve your problem solving. So let me tell you related problem. Also, this PMO is hard, but the level of this problem is related to Maclaurin paper. It's PMO 1 2019. You can use same idea, exactly this idea I told you. Tangent chord angle equal to inscribe angle to solve this problem. Okay. So if you want to learn how to solve BMO2 problem, IMO problems, geometry, the 40, 50 important formulas in geometry, as I said before, feel free to send message to my WhatsApp number in the description and comments. Problem number 4, the ratio of the number of red beads on a chain to the number of yellow beads is the same as the ratio of the number of yellow beads to the number of blue beads. There are 30 more blue beads than the red ones. How many red beads could be on the chain? So let's consider red beads. Number of red beads equal to R, number of yellow beads equal to Y, and number of blue beads equal to B. Then let's write the sentence in mathematics. The ratio of number of red beads on a chain to the number of yellow beads is the same as the ratio of number of yellow beads to the number of blue beads. The first thing, there are 30 more blue beads than red ones. Okay, so R plus 30 equal to B. And how many red beads could be on the chain? So R is what? So if I replace B with R plus 30, and let's cross multiply, R times B equal to Y times Y squared. And so B, we replace it with R plus 30. R times R plus 30 equal to Y squared. And then we want to find all possible values of R. Okay, so if we expand R squared plus 30R equal to Y squared. Now, from this part, I want to use a famous identity that A plus B, let me write it here, or let's write it here. A plus B whole squared equal to A squared plus 2AB plus B squared. If we use this left side, I can say R squared plus 30R. 30R is 2 times R times 15. Now, if I add 15 squared and subtract 15 squared, it will be Y squared. So this part equal to R plus 15 squared minus 15 squared, which is 225, equal to Y squared. Then I take this to right side, this to left side. So R plus 15 squared minus Y squared equal to 225. Another identities, basic identities that you should know is, let me show A squared minus B squared equal to A minus B times A plus. And here we can say R plus 15 minus Y times R plus 15 plus Y equal to 225. 225 is 5 times 5 times 3 times 3, 15 times 15. Now here we know it is positive. 225 is also positive, so this part is also positive. But because here we have negative y plus y, this one is greater than equal to this one. But because we have y in the denominator, this is strictly greater than this. So if I consider the cases, it will be 1, 2, 2, 5. The next one, and here, the number of divisors, if I want to check 5 squared, 3 squared, number of divisors is 2 plus 1, 2 plus 1, 3 times 3, 9. So it has 9 divisors, 2 to 5. If you don't know why, because look, if you want to consider a divisor of 2 to 5, 5, 0, 5, 1, 5, 2, we have 3 cases for selecting which 5s, and for 3s, 3 to the 0, 3 to the 1, 3 squared, 3 cases, 3 times 3, 9. So 1, 2, 2, 5, 3, 75, 5, 5 times 9, 45, so 3, 3, 6. Then if you consider 9, then it will be 25, 8, and 15, 15. But It should be less than this, so we don't consider. So 448 plus, and because of 15, we have 9 divisors, which is correct. So let's consider these 4 cases. It says we want to find R, but I will find all of them to make sure our answers are correct. Okay, so there are 4 cases. First case, second case, third case, fourth case. Let's consider these 4 cases. First case, R plus 15 minus Y is 1. R plus 15 plus Y is 225. Now, if we add these two equations, 2R plus 30, well, negative Y and Y will be cancelled, equal to 226. So 2R, if we subtract 30, it will be 6 minus 0, 6. 12 minus 3, 9. 196. And R will be what? It will be 98. Okay. Now Y will be what? Because R is 98, so 98 plus 15 minus Y is 1. Okay, so we can conclude that 98 plus 115 is 113 minus Y is 1. So this. So Y is 113 minus 1, 112. And B is what? B is R plus 30. R plus 30 is 128. And then the problem says R over Y is Y over B. Let's check it. Not that close mistake. Y over B. It's 98 over 112 equal to Y over B. 112 over 128. Now here, if we divide by 2, it will be 49 over 2 will be what? 56. If we divide by 7, it will be 7 over 8. Now, if we divide by 4, I can say 2 times 4, 32, 8. Divide by 4, 32. If we divide by 4, it will be 7, 7 over 8. It will be okay. Okay, so one answer is this, 98. Now, similarly, we want to find only R's. So, here, if we add these two equations, 2R plus 30 equal to 3 plus 75, 78. So 2R is 48 and R is 24. Let's check third case here. 2R plus 30 equal to 50. So 2R is 20 and R is 10. In the next case, 2R plus 30 equal to 25 plus 9, 34. So 2R equal to 4, so R equal to 2. And, okay, so we found 4 answers. This one, and let's consider for each of them. Let's calculate. R, Y, B, then R over Y, and we should check R over Y equal to B over Y over B or not, to make sure to not have any careless mistakes. So for first case, R was 98, Y 112, 128, R over Y, and these both of them were 7 over 8. It was okay. For next case, case 2, R was 24. And for case 2, because R is 24, then we can say, okay, 24 plus 15 minus Y is 3. So 24 plus 15 is what? 39. So 39 minus 3, 36. Y equals to 36. And B equal to what? B is R plus 30. B is R plus 30, which is 54. Now, R over Y is 24 over 36. we want to see, is it equal to y over b 36 over 54? If we simplify here by 12, 2 over 3. And if we simplify here by 18, it will be 2 over 3 again. And it will be okay. Let's consider case 3. Case 3, r is 10. So let's write r10. Now, for case 3, let me erase this part. R is 10. So 10 plus 15, 25, minus y equal to 5. So 25 minus 5, 20 equal to y. Okay. So 20 equal to y, and b is what? B is r plus 30 from assumption of the problems, 40. Now if we check r over y, it's 10 over 20, 1 over 2. Is it equal to y over b, 20 over 40? Both of them equal to 1 over 2. Last case, fourth case. R equal to 2. Because r equal to 2, if we replace 2 plus 15, 17, minus y equal to 9. So we conclude 17 minus 9 is what? Is 8. 8 equal to what? And b is r plus 30. 2 plus 30, 32. R over y, 2 over 8. Is it equal to y over b, 8 over 32? Both of them will be 1 over 4, which is correct. Okay. So all possible values for r equal to 2, 10, 24, 98, and we've checked all of them are correct. Okay. So we solve this problem completely by using subtraction of two perfect square, writing like this. We have another BMO problem that can be solved with exactly this idea. Let me find that. Okay, so try this BMO problem as homework. Let me tell you, it will be homework number 5. Also, we have AMC problems. I should find AMC problems. Exactly, you should use same idea. If you want to learn those things or improve your problem solving, as I said before, feel free to send me a message to my WhatsApp number in the description and comments. Problem number 5. A 4 by 4 square is divided into 16 unit cells. Each unit cell is colored with one of 4 available colors: red, blue, green, white. The 4 by 4 square contains 9 different 2 by 2 subsquares. Suppose that we color the 16 unit cells in such a way that each 2 by 2 subsquare has one cell of each color. So let's draw. So as you see, each unit is colored with one of the colors, R or B or G or Y. And it says the 4 by 4 square contains 9. Why 9? Because look, 1 here, 1 here, 1 here, 3. Again, 3 on this row, and 3 on last part. So 3 times 3, 9. Okay, so now it says suppose that we color the 16 unit cells in such a way that each 2 by 2 subsquare has one cell of each color. Prove that the 4 corner cells in the large 4 by 4 square must then be colored differently. So the idea we want to use is so much famous in many problems. I saw this idea. Here you say, okay, suppose it is R. At first, I want to prove adjacent corners like this have different colors. Then I want to prove opposite corners. Okay, so let's consider, for example, suppose it is R. Because look, we know all these 4. Let me select this one. All these 4 cells are different. Then if we consider also this one, all these 4 cells are different. So we know we don't have R here. But here we should have exactly one R because we have 4 colors and all of them should be different. So we conclude, for example, if here we have R, then again here we have R. But R is here or here. But because one of them is R, then here we can't have R. Because if it is R by contradiction, then in this place also we have R. Then for this 2 by 2 we have problem. Why here we have R? Because as I said, this 2 by 2 has all colors. This 2 by 2 has all colors. Here we don't have R, but in this 2 by 2 here we should have R. Okay. So, and the idea for this problem is this: when you consider a 2 by 2, when you consider next 2 by 2, when it is xy here, it is xy or yx, or it can be switched. Okay. So here we prove that for adjacent corners the colors are different. Now let's work on opposite corners again. Let's use contradiction. Suppose these are same. So we know because here is R, we have R here because of this part. And again, if we consider this part, or let's consider from here. This is R, so here we should have R because of this R. So here we should have one R. Here we should have one R. So R has to be here because in this 2 by 2 we have exactly one R. So it should be on intersection. Now let's do same thing for this part. We know if you consider this part, if you consider this 2 by 2, again here we have one R. Okay, so here we have one R. Now if you consider this part, these two things, here we have one R also. So if we consider this part, so in this 2 by 2 we have one R. In this here we should have one R. Here we should have one R. So the only place for R is in this part. But now, what is the problem if we consider this 2 by 2? We have two R's and that's a contradiction. So we proved that adjacent corners and opposite corners shouldn't be equal. So we proved that the four corner cells in the large 4 by 4 squared must then be colored differently. Let me explain the thing we've used many times. For example, suppose here is B here without loss of generality, GY. Now, in this part, again, we should have RGBY. So, we have GY, so here it should be RB or BR. Okay? So, we proved this problem complete. If you want to learn, if you want to solve similar problems in AMC, BMO, and other prestigious exams, as I said before, feel free to send message to my WhatsApp number in the description and comments. And let me tell you a similar problem. How many homeworks did we have? Homework 5, homework 6. Suppose we have a 4 by 4, we wanna fill cells with 0 or 1 such that sum of 4 cells of each 2 by 2 is even. How many ways are there? It's similar problem. Ways are there? You can try this one. And if you have question, you can feel free to send message to my WhatsApp number. Problem number 6. Let Mn be fixed positive integers. Prove that there are infinitely many triples of positive integers x, y, z such that for each pair of values Mn such that x to the Mn plus 1 equal to y to the n plus z to the n for each pair of values Mn. For this problem, we try to use small examples. For example, if n equal to 1, it will be x squared. It says m and n are fixed positive integers. X squared equal to y plus z. So obviously, we have many answers for this because we calculate x squared. For example, 5 squared, 25. X, y, z are positive integer. You write 124 up to 22, 23 up to 24, 1. Okay. So here it is obvious. If power of one of them be 1, it will be like this. If m is 1, then we can say x to the n plus 1 equal to y plus z to the n. So, for example, you consider any number. You say, okay, x and z are equal. Xn plus 1 equal to y plus x to the n. So, for any x, for all x, that are positive integers, it means belongs to positive integer, it will be okay. Now let's consider, for example, if there are at least 2. So let's check n equal to equal to 2. Now, we want to solve x to the 5 equal to y squared plus z squared. Now, suppose we find one answer for this. We want to see, can we, because it says what? It says infinitely many triples. I want to see if we find one answer. Can we find infinitely many answers from that? This is one approach. Suppose x1, y1, z1 works. Now, if we, instead of x1, I consider a squared x1, then we have a to the 10. And then we consider x is this, y is a to the 5, y1, and z equal to a to the 5, z1. Then x to the 5 equal to a squared x1 to the 5, which is a to the 10 x1 to the 5. y1, y squared plus z1, y squared plus z squared equal to a5 y1 squared plus a5 z1 squared. So it will be a10 y1 squared plus a10 z1 squared. And now we want to see, are they equal? A to the 10 x1 to the 5, which is x to the 5. Is it equal to y squared plus z squared a to the 10? y1 squared plus a to the 10 z1 squared. A is positive integer, okay? And it is equivalent because a is not 0, x1 to the 5 equal to y1 squared plus z1 squared. And we will see it works. Okay, so here we will see that if we find one answer, then we can find infinitely many answers. Here, if we consider y1 equal to 2 squared, z1 equal to 2 squared, then it will be 2 to the 4 plus 2 to the 4, 2 to the 5, and x1 equal to 2. It works, okay? Now so here we are using which idea considering a small example, so much important. Now let's generalize this for general m and n. X to the mn plus 1 equal to y to the m plus z to the n. At first, let's prove that if we find one answer, then it will be okay. We can find infinitely many answers. Suppose x1 to the mn plus 1 equal, you don't need to write these things m2, n2. You can start from this part on your answer sheets, okay? And small examples are for only ourselves, not writing in answer sheets. So, plus z1 to the n. Now, if I consider x equal to a to the, look, I want a to the power of something that times this. Let me tell you, y1, y equal to a, y1, z equal to a, z1, and then a to the power of this one should be equal to these things. So, it will be what I want for previous one. I saw that 5 times 2, 10. Look here, we had 5, 2. We've considered LCM to reach that. So I say LCM of mn plus 1, m and n, or product of them. Okay? So let me move them to write the power better. I say I have mn plus 1. Let's write mn. And for this one, y n times mn plus 1. Next one, m times mn plus 1. Okay, so x to the mn plus 1 will be what? Will be a to the mn x1 to the mn plus 1. So it will be a to the mn times mn plus 1 x1 to the mn plus 1. Now y1 m plus ym plus y zn equal to ym is this to the power of m. So it will be a this one to the power of m, mn plus 1 y1 to the m plus z to the n. You multiply the power by n, it will be mn plus 1 z1 to the n. That's yours. Now, as you can see, these coefficients are equal in all of them. And we know x1 to the mn plus 1 equal to y to the m plus z to the n. So we found infinity. Now we should find one answer. Okay, exactly. Look, we are working like small examples. M equal to 2, n equal to 2. That was the key point for finding the solution. Now, here for y to the m plus z to the n, I want to reach to 2mn plus 2mn. Then I can say it is 2 to the mn plus 1. Then I can say it is equal to x. I want to find one answer. y1, z1, x1 to the mn plus 1. So, by this case, x1 equal to 2, y1 to the m equal to 2 to the mn. So, y1 equal to 2 to the n, and z1 equal to 2 to the n. Okay, so it is our first answer, and here we prove by this x1, y1, z1, we can multiply it by a, and a is positive integer. So x is what? Let's write a to the mn times x1, which is 2. Y is a to the n times mn plus 1. y1 is what? 2 to the n times 2 to the n. And z is what? Z is a to the m times the mn plus 1 times z1 is 2 to the n. Okay. And for all a that are positive integers belongs to positive integer, we can say it is our general answer for x, y, and z. Okay. So I told you around 6 homeworks. You can work on them. Look, these approaches here, we've used what? This idea, considering small examples. Let me tell you some problems that you can use this idea. Homework number 6, homework number 7. Okay, this is BMO2 2022. You can solve this problem with only small examples. Homework 8, BMO2 2023, question number 3. Okay, homework 8, question number 3. This problem of BMO2, last BMO. At first it seems to be hard, but if you check a small example, it will be so much easiest problem. And I released the video of solutions of BMO2 2023. You can use that. And also, if you want to learn important ideas, important approaches for solving problem, improve your problem solving, learning 40, 50 important ideas in each topic, as I said before, feel free to send message to my WhatsApp number in the description comments. Thanks for watching this video.